Yuvraj and these are my team members.
Nitin.
Yuvraj. So our topic is cache memory and mapping function. So in that we start from the cache memory introduction. The cache memory, it is one of the best memory. It is used in the specific conditions, and the cache memory is high speed memory which give the good interface to the user, and it is usually used in the specific condition. It is costlier than the comparing to the main memory, and the memory it is stores in the size of the MB stand for megabytes. And going through some advantages of the cache memory, it is faster and giving good interface to the user. Disadvantage of a cache memory, it is costlier and not good in the every users. It can store in the small data, and as your cache memory is used to store the frequent data by the user, it is not store the long period of the data. So next part will continue by the Vikas.
In the cache operation, there are two types of cache operation. First is cache hit and one more is cache miss. In the cache hit, it goes across the multi-levels of caches, in which it goes to the main memory, which will fetch the data and process to the CPU. If the data is found in the processor, then it is a cache hit, and the data will be sent to the processor in nanoseconds. Next is cache miss. If the data is not found in any of the main memory, the CPU will not fetch the memory. It will use the replacement policies like FIFO or LRU, which when it is full man. Next is cache coherence problem. Cache coherence problem occurs in multiprocessor systems, which will have its own caches. So it will, if the multiple caches has the same copy of the same memory, the first memory will run, but the second memory will not run because it has the duplicate of the same memory with the same value. But for that problem solving, we will use directory based systems. In directory based systems such as protocol, it will keep the it will keep the track of the memory spaces, and it will keep the updating the memory values. Such as if the processor 1 will have load 1 in the cache, but the processor 2 also will have the load 2. In such way, directory based systems or protocols like MSI will update the process 2 or process 1 into the update level. Means we have to add it and it will update it like 20 in its cache. But if the P2 has still this old value, then it will creates the cache incoherence. Means it will create some problem in the main memory to CPU.
Mapping function is nothing but the memory stored from the block. It decides which memory block should go in the cache memory. In memory block, it is stored in the blockwise word. Each word is stored in the block, and in cache it is stored in line. Each block is stored in line. Memory mapping function decides which block should go in which line. It has three techniques: direct mapping, associative mapping, and set associative mapping. Direct mapping, the cache block for a memory block is decided by the memory address. The 16-bit memory address is split into tag. Word offsets picks one word from the 16 inside the block. Block index shows which cache block the data must go to. Tag identifies the memory block and is used to check hits or miss. In this, the words are stored in the block 1, block 2, block 3. 128 words. Those words are these blocks are stored in the cache memory in 16 words. Block 0 in line 2, block 1, line 3, block 2, line 4, block 2.
I will be explaining another type, associative mapping. Associative mapping allows any memory block can be stored in a cache. Can be stored in any cache block. With the tag used to identify and match the correct block during access. Memory address is divided into two parts. One is word offset, which consists of 4 bits. Choose one word out of the 16 inside a block. Tag consists of 12 bits. It identifies a memory block compared with all the cache tags. Working. Oh, this is the main memory and this is the cache. Main memory consists of 95 blocks. From this, store the cache memory. It is divided into two parts. One is tag and another is word. Word is of block. So tag will be compared with all the addresses. And next one is another type set associative mapping. Set associative it is a combination of direct mapping and associative mapping. It consists of the memory address is divided into three parts. One is word offset and another is set index and tag. The word offset is divided into 4 bits in which select one word out of 16 words. Set index it identifies which set the block must go to. Tag identifies which block inside that set is the correct one working. This is the main memory and this is cache. First of all, the cache is divided into sets. That the main memory identifies which block is stored in which set. On the basis of that, the set will decide which set it has to be stored. And the tag is consists of 6 bits and the word is consists of 4 bits.